All right, so now it looks like we're. All right, so again, that quiz had 2 grades. One grade came from is it parallel or are the 2 lines parallel, perpendicular, or neither? So this was, we'll do red. This was 1 grade right there. Those 2 pieces, it was 3 questions total. The other grade was that was only 2 questions total there. This last one, a lot of kids didn't see that on the graph, there were the 2 points that were on the line, but then there was a third point that wasn't on the line. That's the one there that you were supposed to find the distance between the line. A whole bunch of people just found the distance between the 2 points on the line. Like that's what almost everybody. A few people understood the question and did it correctly, but not many. So what I'm going to do to try to help out with all of it, and because frankly, there's not really that many ways to either teach that or to assess that, I'm going to do a review video. And in the review video, I'm going to do the exact same quiz you took. It'll be, I mean, there are 2 versions, but I'll pick one version and I'll just do the review video and go through and work the entire quiz out. And I'll make another version, look exact same. I'll make another version that will be your retake version. So if you watch that video, I would say you probably don't even have to practice problems like go to the iExcel or go to the book problems. You watch that video, take a break, come back 30 minutes later, watch it again. You can fast forward, do whatever, but pause it when I get to a problem and try to do the problem. If you can do the problem, you're in pretty good shape. If not, watch it again, watch the steps, and then do that, repeat that. And then maybe repeat it one more time before whenever you're going to come in and take the quiz. I don't see how you don't do well. Like it's going to be the same thing. The video will be me basically doing a quiz, just like you're going to come in and do the quiz. So yeah, that should allow you to get 2. And I'm not going to require, even if you got a 40, I'm not going to require tutoring, not even going to require iExcels. The only thing I might do, if it's a student that I'm like, I don't know that they are ready for this, I might ask a question and say, okay, what would the first step be if you wanted to know if 2 lines are parallel, perpendicular? I might just ask something like that. Get the question right, then I'll let you do. If you don't, then either you got to wait and come back, or you can stay in and practice, and I can try to help you or something like that. But yeah, just watch that video, make sure you're ready, and when you get back, you can do whichever one you want to do or both. Let's see. I'm also probably going to wind up because I don't think the grades are going to be great from today. I'll probably go ahead and do that same thing on that one since we have a week off. I might as well just go ahead and create that. Can't hurt. So know that I'll probably do 2 of those review, 2 separate videos. I'm not going to do all of them. Any questions on that? Any grade stuff in general? Before we do new lesson. All right. And you do have a quiz today, so if you didn't hear me say that earlier to somebody. All right, so what does congruent mean? It means that they're shoot here. It means they're the same, right? It means that they are either the same measure, the same length, we said. We're now getting into talk about congruence with an entire shape. Don't mean the same thing. It basically means if I say those 2 triangles are congruent, it really means they're the same triangle. Because that one's over there and that one's over there and that one's over there. But what we've done is some kind of or multiple rigid transformations. What did we say a rigid transformation was? That was that definition you wrote down one day when I had to write 3 things down. Oh, then you can find it real quick. Say we do not change the shape at all as far as the measure of the angles, the length of the sides. You could say we don't change the distance between the points. So the distance, like if it's on a coordinate plane, the distance from that point to that point would match the distance from that point to that point. Again, that's the same thing as saying the sides are the same length. That's what rigid means. We will get into another kind of transformation where we do change the size of the image, But rigid transformation, keep the image the same size, same angle, measures, everything. So congruence means if two shapes are congruent, we could take one of them, we could perform different transformations. So we could reflect it, rotate it, translate it, so slide it, flip it, rotate it, spin it, whatever. And that triangle would eventually be able to land exactly on top of that triangle. That's the true definition of congruent figures, congruent images, congruent objects, congruent shapes, whatever it says on that in the problem. So just understand that's the true definition of it, because there are some conceptual questions I've seen on the district stuff where you kind of need to understand that. But here's how we're going to use it for the most part. If I give you, we're going to start with triangles, but this will continue when we get into other shapes. If I give you two triangles and I tell you that triangle is congruent, so if you don't remember the symbols, write that symbol, that means congruent. The difference between congruent and equals, again, has to do with the shapes. Congruence means that that triangle would lay exactly on top of that triangle. Equals would be more about the sides of it. That side is the same length as that side, like actual numbers, basically, not just shapes. So that's the only difference really between congruent and equals when you start to see them. Sometimes they do congruent, sometimes they do equals. So with that in mind, if I'm telling you those two triangles, oh, and typically you'll see more of this here, a triangle symbol, not really the word triangle, but same thing. So if I'm telling you that is true, then again, that means there's an angle that corresponds and is congruent to angle A. There's an angle that's corresponding and congruent to angle B, and an angle that's congruent to C. Same thing with the sides. There's a side over here that's got a matching congruent side over there. The parts all have congruent sides. So this is the simplest version of it, but we'll get into other math. Harder. What would X be? Fill other stuff in, but what would X be? Same. It is. We would say, okay, well, there's, we just said there's a congruent corresponding angle. So that would be the equation. Like that's the way I would set up an equation if I had more than just X there. Like if it, was 7X subtract 10, and then that was 58. And then I could solve for X. But that's the simple version. There's only an X there, so we just say that equals that. Right? So if we had different numbers, well, actually, no, not different numbers. I mean, not technically different numbers. Willie. Oh, I have to give you, let's do a Y this time. What would Y equal? Yeah, try still same triangles. Triangles are congruent. So it'd be what? Wrong. How could that be wrong? You just did it, right? What changed? It did change variables, but that's still just a variable. What else changed? Look, you picked. Oh, I meant to tell you to copy down. We'll go back up and you'll copy in a minute. So again, look at that image. Say it again. What was at the top? On the right. Well, the triangle. Where A is, what's over there? Down here. What's the top? Yes? Yeah, when the triangles are congruent, the parts match up based on the name. So I'm about to give you something to write down. So first, though, copy this down. You need to have the picture. I forgot to tell you to copy that. You don't need the numbers. Don't do it without the numbers. Well, I guess the numbers wouldn't have hurt. That would have been fine too. But yeah, I forgot to tell you to do that. So do that. Copy that down. Then I'll tell you everything you need to write. What I'm about to tell you is like fireworks going off, capital letters, exclamation points, whatever you need to do to be able to find it again later. This is one of those kind of things. You have different highlighters, different colors that you use. This would be one of those times to get those out. So when you're done copying it down, just kind of put your pencil down and I'll. Yep. And then you need to copy like this part too up top, not just the triangle. The names of them. That would be going over. That would be cheated for now. I spun around a little. Don't say nice about it. Had a copy? Yep. You can copy the next part if you're not here for some reason. All got it? Go a couple right. Set your hand up or you. Okay. You got all that top part written? Gotta write all that, yeah. All that stuff at the top, you gotta write. Especially, and again, if you want to write a shorter version, instead of writing the word triangle, this is fine. Also, I erased it, but I don't know why. You can write it that way instead if you want. Either one works. I gotta go fast. Yeah, so late. Writing it down. I'll go ahead and get started. All right, so here's the next part. You're right. This is kind of goes along with this image. Big capital letters. Like I said, fireworks going off. I don't know, how did I word it? I guess we'll say you cannot tell. Cannot tell. I'm going to say triangles for now. It applies to all shapes, but since we're going to do triangles for a while, let's say triangles. You can't tell what angles or sides. You cannot tell what angles or sides of triangles are congruent by looking at the images. So you cannot tell, so basically you can't tell what's congruent by looking at the images themselves. Not tell what sides or angles are congruent by looking at the image. And then the last part again, big capital letters, double underline. And I'll say, don't write anything down yet. I'll say it two ways. You can think whichever way you like. I knew you were doing that. I knew that's what was going on. You have to or you must, either one works, use the name. I'll show you what that means. You have to or you must use the names. What's that? Before I said you have to or you must. You cannot tell what is congruent by looking at the images. And what I just showed you is the reason why. I could turn this. So let's say A is congruent to F. Like that's the way it works. That's 62. That's what matched up with what? That's no actually. Hold on just a second, bud. 58, 62, and then 60. You just said it, you can get it from one of them. So this one, then we said this. So again, if that's the three numbers, I could always turn this triangle once, and that doesn't mean the top's going to match up, right? I mean, if they match up now, if I turn that triangle, they don't match up anymore. You can't look at the image. I could flip it. And if I flipped it, meaning I turned it onto its other side, well, now the 60 goes to the right, and the 62 would be on the left. So again, the bottom wouldn't match up if I flipped it. I cannot look at the images to tell what matches up. But I can always say, well, if it's named ABC, then A matches up or is congruent to F. B is congruent to E, and C is congruent to D, which is the way that I have the numbers talking. That will always be true. So if I flip it, turn it, whatever, no matter how I flip it, D is always going to be 62. So therefore, it'll always match up with C. Again, turn it, flip it, do whatever. E is always 60. So it will always match up with B. No matter where it looks like it is, the letter, the name of the angle will always correspond to the other part of the other triangle. So you have to use the name. Same thing is true. So again, you can write this angle A congruent to angle F, angle B congruent to angle E, angle C congruent to angle D. And we could do the same thing for the sides. We just use two letters. So side AB would match up with the first two letters here. So that. So you can do the same exact thing with sides as well. I want you guys to finish it off. Do BC. And what's the other one? AC. And finish it off and write what those would be. We got to hurry. Maybe the super fast version of the next one. Just completely going to do it for you. So you should have written that. BC is congruent to ED. AC is congruent to FD. When it comes to the sides, it could be possible that they could switch the letters. Side FE is the same thing as side EF. I think you're normally going to see them written in order based on where the letters are. I doubt they'll flip them, but I would say that's still fine. All right, so that's the big one. That's how, and that leads to equations. So I want you to write the equation that would allow you to solve for Z. So look at the name. Z is down here, if you don't know what I'm talking about. There's the Z. What equation would allow you to solve for Z? Based on the way it's named up top. Start kind of giving you hints. That's where the Z is in that angle. You know the answer? I will. Yeah. And then you just solve out for Z. And then remember, again, in triangles, once you solve for a variable, make sure you read the question because a lot of times they're going to ask you for the angle, not just the variable. Yeah. Try to guess before I write it up. Just want me to write it. Sorry. So again, if we know angle, again, based on the name, angle A is congruent to angle F. That means they are the same measure. Well, the measure of F is 2Z plus 10. That's what all that means in there. That means that is the measure of that angle. Well, that's got to be equal to, actually, let's do this. Angle F has to be equal to angle A. Again, that comes from the name. They have to be equal. Well, now I'm just plugging stuff in. Angle F is 2Z plus 10. Angle A is 15. And then you can solve, just make sure after you solve, you read the question, because the question might be, what is the measure of angle F? And then you have to take what Z is, plug it back in, and solve for angle F. Last thing, and then we really got to get going. Really quickly, draw that figure. It's in your book, but I'm just going to have you draw it while I also at the same time explain it. The arrows means we have parallel lines. So these are just reminder stuff. Top line is parallel to the bottom line. Left line or left side is parallel to the right side. That's what those arrow things mean. These markings are congruence marks. So the top side is also the same length as the bottom side. So make sure you kind of label those things. Parallel, congruence mark, something like that. So the left side is congruent to the right side. True or false? I can say for sure that is a rectangle. What do you think? Think so? Yeah. I actually told the first few classes we could, but I was wrong. Because we don't know the measure of that anyway. I don't know that it's 90. It looks 90. Oh. Because I'll exaggerate and show you why we can't say that. I told them it was earlier. That parallelogram. And a parallelogram, those are parallel. Those are parallel. Those are the same. Those are the same. A parallelogram has the same properties. I would need to know that that angle is 90 in order to say for sure it's right. If I knew that one angle was 90 here, then I could then say that the other one's 90, and I could say the whole thing is them. a rectangle, but without knowing that, it could be a parallelogram. So again, last piece, we did this lesson. So when it comes to congruent triangles, this is the way that we would prove those are congruent. We would say, well, I know that angle is congruent to that angle, not that one, because of two parallel lines in transversal. That's parallel. So that's parallel. That's parallel. And that's my transversal. So it creates that fact that we have alternate interior angles. I did not hit that button. That button? Is that still working? Yeah, yeah, that's right. So those would be congruent there. These would be congruent here. And then if those are congruent because they have to add up to 180, like all triangles have to add up to 180, we can't say it's 90, but we could say that they're parallel or they're the same measure. We don't know what that measure is. So that's kind of how you use that old lesson in a new shape to figure things out. All right, so go ahead, put your stuff up. Boy, you guys don't have as much time, so I might give you some. I mean, I'm going to tell you something anyway, but make it fast for one addition.